Bismillahirrahmanirrahim. Assalamu alaikum students, how are you? I'm sure you will be fine. Today we will discuss chapter number 3 particles, and today's topic is the particle model of solid, liquid and gas. By the end of the lesson, you will be able to describe particle model and its assumptions, draw scientific model of solid, liquid and gas. In this chapter, we are going to review what we know about solids, liquids, and gases. We are going to learn about a scientific model that can be used to describe how the particles in all three states behave. This model is called the particle model of matter, and it will help us to understand much more about the properties of solids, liquids, and gases. Let's get started. According to its first assumption, the all substances are made of particles. You can see the microscopic view of matter in the slide. According to the second assumption, the particles are attracted to each other, some strongly, other weakly. Actually, particles of matters of same substances, such as the same element, are attracted to one another. The force of attraction tends to pull the particles close together, as you can see in the diagram. According to the third assumption, the particles move around. Actually, each particle moves freely through space. The motion of particles in a liquid is kinetic energy. When a liquid gets warm, the particles move faster. The particles have more kinetic energy. According to the fourth assumption, as the temperature increases, the particles move more rapidly. Actually, particles move rapidly in all directions but collide with each other more frequently than in gases due to shorter distance between particles. When an increase in temperature, the particles move faster as they gain kinetic energy, resulting in increased collision rate and an increased rate of diffusion. Each state of matter behave differently and the particles in each state behave differently. This diagram compares the particles in a gas, a liquid and a solid. This is all for today. You will learn and write this question: how will you differentiate between three physical states of matter with examples? You will look page number 32 of textbook and workbook page number 18 and 19, which is related to this topic.
In this video, we're going to look at the three states of matter: solid, liquid, and gas, and see how substances can change from one state to another. To do this, we're going to use a model called particle theory, or sometimes kinetic theory, which helps us explain how the particles in each state behave, by considering each of the particles as a small, solid, inelastic sphere. In solids, there are strong forces of attraction between the particles, which holds them all close together in a fixed position to form a regular lattice structure. And because the particles are fixed, the overall substance keeps a definite shape and volume, so can't flow like a liquid. The particles can vibrate around though, so you can imagine them constantly jostling against one another. Now, if we heat up a solid, its particles gain more energy and start to vibrate even more, which weakens the forces between them. And at a certain temperature, which we call the melting point, the particles will have enough energy to break free of their bonds, and so the solid melts into a liquid. In liquids, there are only weak forces of attraction between the particles, so they're free to move around and are arranged pretty randomly. However, the weak forces of attraction do mean that the particles tend to stick together and are fairly compact. This means that they have a definite volume, even though their overall shape can change, allowing them to flow to fit a particular container. If we then heat up our liquid, the particles will again gain more energy, and this will make the particles move around faster, which weakens the forces holding the particles together. Then, once we reach the boiling point, the particles will have enough energy to break the bonds altogether, and so the liquid boils or evaporates into a gas. In gases, the force of attraction between the different particles is very weak, so they're basically free to move around by themselves. This means that gases don't keep a definite shape or volume, and instead will always fill a container, as they spread out as much as possible. Now, we normally say that gases are constantly moving with random motion, which is a bit confusing because gas particles actually move in straight lines. They don't randomly swerve. What we really mean by random motion is that the particles can travel in any direction, and they'll end up being deflected by solid walls and other gas particles randomly. When we heat up a gas and the particles get more energy, and so travel faster, the gas will either expand if the container it's in is expandable, like a balloon, or if the container is fixed, then the pressure will just increase. On the other hand, if we cool the gas down enough, then the particles won't have enough energy to overcome those forces of attraction between them, and so bonds will start to form between the particles, condensing the gas into a liquid. As we cool down the liquid even further, the same thing happens. The particles won't have enough energy to overcome the attraction between the molecules, and this time even more bonds form, fixing the particles in place and freezing the liquid into a solid. Now, the last thing we need to mention is that if we're working within a closed system, changes in state won't change the mass at all, as there's still the same number of particles. However, the density of the substance will change, with solids having the highest density, liquids having slightly lower density, and gases having the lowest density of all three. That's everything for today's video. So if you enjoyed it, then do give us a like and subscribe, and hopefully we'll see you soon.